everybody. Today we're going to be talking about dilation. So in your journal, what I want you guys to do right now is I want you guys to understand the difference between stretching and compressing. So here's what you're going to write down. You're going to write down, if we have the original function called f of x, and I put a number on the outside of it and multiply it, and that value of a is greater than 1. Any number that's greater than 1, that's going to be called stretching the graph vertically. So it's going to call it stretches vertically. And we're going to do some examples here. Okay? So right now, what's the parent function for the absolute value of x? What's the parent function? Y equals the absolute value of x. That's the parent function. So what I want you guys to do right now is we're going to make a function that stretches this vertically. I'm going to say, what if the function was y equals 4 times the absolute value of x? What would be my value for a? My value for a would be a 4. Is that greater than 1? Yes. This would be considered something that's stretched vertically. That means you are actually going, stretching means going towards, vertically, towards the y-axis. If you think of the vertical axis, which one is running vertically? Yeah. Vertically is the y-axis. So this graph is going to be stretched towards the what? Towards the y-axis. So when you guys think of the word vertically, what do I want you to think of? I want you to think of the y-axis. When if you think of the word stretches, I want you to think towards. You're stretching towards the y-axis. So go to your calculator, hit y equals, clear out all of these parabolas. Let's type in the original parent function, bless you, parent function for the absolute value of x. Now what's the keystroke? Math, right arrow, enter. That's one way to get your absolute value. So right now, can everybody please just hit the graph button and take a look at this. Now this one, I'm going to hit zoom and I'm going to hit the number 5. I'm going to square it up. So now all your grids are squared up. So now they're like tiny little squares. So that's your original function. Now watch what happens when I go y equals, and what do I do in front of it? I put a 4. Now, right arrow, enter, x, graph. So here we go. What was our original function right here? Our original function was y equals the absolute value of x. And this one was y equals 4 times the absolute value of x. Can everybody see how this is going towards what? It's going towards the y-axis. Imagine yourself stretching with your arms in the air. I said stretch to the sky. Your arms are going towards that y-axis vertically. Okay? Now, go to your y equals if you would. Change this number from a 4. We're just going to say, instead of 4, we're going to say, what is 8? Math, right arrow, enter, and an x. This should actually be going even more towards the y-axis. Okay? So, in summation, I go back. If the a value is greater than 1, what's happening? It's being stretched vertically. Okay? Well, what if our a value for a times f of x, what if our a value is less than 1, but it's greater than 0? Kind of like this guy right here. What's that number? That's a half. Would you agree a half is between a 0 and a 1? We call this not stretch, we call this compress. This is compressed. We'll call it compress instead of compresses. I will say compresses. We'll say after. Compresses horizontally. I'm sorry, not compresses horizontally. Compresses vertically. Sorry. Compresses vertically. Okay. So this would be your final answer because compresses means away from. It's going away from what? It's going away from the y axis. So when you see the word compress, I want you to think it's going away from. When you see the word vertically, still think of the y-axis. So let's give us some examples here of this happening. You could say y equals what we have here, a half of an x. You could say y equals 1/8 of x. So any decimal between a 0 and a 1, what's going to happen? It's going to compress vertically. That's what I want you to have in your notes. Okay? And now we're going to test it. All right, go to your graphing calculator. All right, the blue one is our parent function. I want you guys to go to y equals, and I want you guys right here where you have a 4, all right? I want you to insert second delete. We're going to insert a 1, and then a divided by 4. Actually, we'll change it to a 2, just like 1 divided by 2. So do a half of x. And down here, we're going to insert, so second delete, we're going to now insert a 1 divided by 8. So how do we insert stuff? You see it says I and S right there? It's not short for insurance, it's short for insert. You're inserting. So you hit the blue button, which is the second, then insert, and now you can insert those. So which one do you think is going to be further away from the y-axis and closer to the x-axis?
I think 1/8.
1/8?
No, I think 1/8. No, I think half. Would be closer.
All right, find out. There's the original. All right, so let's label these, okay? Let's label these. This was y equals the absolute value of x. This one was y equals 1/2 absolute value of x. And this one was y equals 1/8 the absolute value of x.
So I was right.
Right. So, but right now I want you guys to understand, here's what's happening. We are going not towards the y-axis, we are going what? We're going away from the y-axis. That's why we use the word, everybody, we use the word compress, because we're going away from the y-axis. Before, what did we say? We're going which direction? We're going towards, and that was not compress, that was stretch. Okay. Let me understand. You can also take arms and you can compress them away from your body. Okay? Alright? So if I was to take this and push it down away from, you could say I'm compressing your arms away from. Okay? So stretching goes towards, compressing goes away. Towards, away. Does that make sense? Hopefully. Now, we just talked about two things right now. We talked about what? If the a value was where? In front of the function. Now we need to go down here. And we need to talk about what if the a value is right next to the x, not on the outside, but on the inside. If the a value is greater than 1, we say one thing's happening. If I have the exact same thing, but the a value is less than 1, but greater than 0, we're going to call that something different. I want you guys to understand, if the a value is next to the x, which axis deals with x? The x-axis. So we're going to use the word horizontal. Okay? Now, what do we call something that's going towards the x-axis? What word do we say going towards? Stretch. So if the a value is a fraction, that means it's going to be stretching. Okay? So if it stretches horizontally, that means your A value is going to be some fraction. Why is that? Because if it's a fraction, it's going what? It's going towards the x-axis. So stretches horizontally means what? It means towards the x-axis. If I compress something horizontally, that means I'm going away from the x-axis. Okay? So I'm going away from the x-axis. This is if the A value is what? Next to the x in the function. Okay? So we say compresses, which means away from, or stretches, which means towards. And horizontally, the word horizontally, what do I want you to attach it with? Horizontally means you're dealing with the x-axis. So I want you to make that connection. Horizontally deals with the x-axis, and vertically deals with the what? Vertically deals with the y-axis. Okay? So, how we describe it, now sometimes they look the same, but how we describe it is going to be different. Okay? So what we're going to do right now is we're going to do a couple of examples with this and a couple of examples with this. Okay? All right, go to your calculator, hit y equals. Now, what I want you to do is I want you to take this half right here, and now you're going to go and you're going to say second insert, and you're going to put a half next to the x. Okay? Then you're going to delete this. You're going to go inside this absolute value bar. You're going to hit second insert, and we're going to type in a 4 right here. Oops, sorry. Here we go. Now, I want you guys to understand, the only thing that we did different is we took the number that was on the outside and put it on the inside. Now, you're going to notice some graphs look the same, but we have to describe them differently. Okay? And I'll explain why we have to describe them differently. It doesn't really matter with the absolute value, but it does matter when you have something that's being squared, if you put it on the inside versus the outside. Okay? So right now, this is our original function. This A value is less than 1, but greater than 0. So how would I describe this? I would say this is actually being stretched. Which direction? Would you agree that this graph is going to be closer to the x-axis than this graph? Now, let me go back real quick. So understand, if you see it next to the x, like that factor is next to the x, then you're dealing with what? Either horizontal compression or stretching horizontally. Okay, it's one or the other. So if it's between what? Between 0 and 1, we're dealing with what? Stretching. Okay? There we go. Now what about this one? This number, this A value is what? It's greater than 1. It's going to be compressed. But it's going to be compressed. You're like, well, that's going to be going closer to the y-axis. But we're going to be calling this going away from the x-axis. We're going to say compressed horizontally. I know it's kind of confusing to start out with. That's we're trying to get the vocabulary down. Okay? So now I'm going to hit graph. There's your original function. There's the one that's getting stretched. There's the one that's being compressed. Stretch means what? Stretch means it's going what? Towards. This is going towards the x-axis. Compressed means it's going away from the x-axis. Okay? So this one is being compressed away from, and this one is being stretched towards. this a value is what? This a value is equal to a half, and this a value is equal to a 4. But where was it next to? It was next to what? The x, not out in front. All right. Look at the red function. Look at the purple function. This one I said it was compressed. This one I said it was stretched, even though they're the exact same as far as the way they look. But understand, this function, if I wrote it out, was y equals the absolute value of 4x. This one was y equals 4 times the absolute value of x. So if it's on the outside, you're dealing with something vertical. If it's on the inside, you're dealing with something horizontal. So you need to know the difference between those two. Okay? So that's the main thing. So now we can go back to our PowerPoint, and it says, where is that? That's on the outside, so we're dealing with something that's dealing with vertical. But is that going towards the y-axis or away from? Away. So what do we call that? We call it compressed vertically because it's going away from. Okay? Ooh, that's on the inside. So what we're dealing with some type of horizontal something. So is it going away from the x-axis or is it going towards the x-axis? It's going away from. What word means away from? Compressed. So this would be compressed horizontally. Because it's going what? Away from. Everybody? Here is the coup de grace, like the final, can you figure out the 4 things that are happening in this graph? Write this down right here, and this is the last thing we're going to do before we start our assignment. This is the final thing. You have 1, 2, 3, 4 things. I'm going to highlight what those 4 things are. Here we go. This does something right there. So that's one of the things that we're going to have to figure out. What's happening because of that blue negative? Ooh, there's a half right here. That's dealing with something we just talked about. There's an x minus 5 in the parentheses. That's something we talked about yesterday. And then at the very end, we have a plus 12 and a half. So there are 4 transformations happening. I apologize for that missing little area, but you're just going to have to deal with it. I know some of you are like, please fill it in. Here's what happens if you fill it in. You're not going to like it. I'm just letting you know.
Okay.
See? So we're just going to let it be. Okay? All right, everybody, look at the negative. Is that on the outside or the inside of the function? It's on the outside. We're going to have some type of reflection. What's it going to reflect across? It's a negative f of x. It's on the yes, across the x-axis. That's one of the things. Across x-axis. I'm sorry, I didn't all fit in there. Forgive me. Right? So it reflects across the x-axis. Ooh, that half is that on? That's on the what? That's where it's a times f of x. And what's my a value? My a value is less than 1 but greater than 0. So what's that? What's happening there? We're dealing with it's compressed vertically. It's compressed vertically. Look at your notes. You will clearly see that if the number's on the outside and it's between a 0 and a 1, you would say it's compressed vertically. It's in your table. Okay? It's in your table. Ooh. Here we have a translation. It's translated 5 units to the right. It's translated 5 units. You're like, wait a second. No, you're wrong, Mr. Moody. That says x minus 5. But what number minus 5 gets me back to 0? Positive 5.
Oh, I see what you meant.
And last but not least, it's also translated which direction? It's translated up 12.5 units. It's going to go up 12.5 units. Okay? Those are the 4 things that are happening in this graph. By the way, this is an example of something you might see on a quiz, where I give you an equation to say, give me the 4 transformations that are happening in the graph. All right? If you get all 4, you get 100. If you get 3 out of 4, you get a 75. 2 out of 4, you get a 50. 1 out of 4, you get 25. And if you don't get any of them right, then you earn a. Have a wonderful day. Study up. Good luck.